So this is multi-arch VM deployment options with KubeVirt and CDI. David and I have been working on this for about a year and a half, and we're an IBM infrastructure and Red Hat partner engineers, and our major project is virtualization on OpenShift container platform. But this time we got the opportunity to work upstream to actually do the port to S390X. And these are our email addresses if you want to chat with us further. And go to the next slide. There we go. So what is KubeVirt and containerized data importer? We've seen pictures like this a couple times. It's a Kubernetes facility, Kubernetes add-on operator that allows you to run virtual machines inside a container. You don't have huge performance hits with that unless you're running your nodes on themselves on virtual machines. We'll talk about that a little later. It allows you to reconfigure and relaunch existing VMs and play with them, template them. Containerized data importer allows you to use persistent volume claims as disks for KubeVirt VMs by way of data volumes, and to import, clone, and upload those VMs from your friends, or either registries or from external storage. So we've got some pretty pictures. CDI, import, clone, and upload are supported for VMs that are stored externally in VMware installations via the Virtual Disk Development Kit, VDDK, which is available, is a proprietary closed source library, correct me if I'm wrong, that runs only on x86, and that creates a little bit of a problem for importing VMware virtual disks or virtual machines from VMware into Kubernetes. But if your major platform is S390X, is not x86, but on the other hand, most of your virtual machines that are stored in VMware are x86. So what we get with KubeVirt on Kubernetes is much wider access to a lot more architectures, and we'll see that in the next. So for example, we've got our AMD 64, which is taken to be standard. Some people say nobody runs anything besides that, but in actual fact, we've seen some really nice presentations on ARM64 and the extending that to the NVIDIA GPUs, which run on both the ARM64 and AMD 64 platforms. So there's many reasons why you would choose any one of these combinations for the specialized uses, either the low power, the fact that it's RISC, the fact that you've got a Raspberry Pi and it only costs you $10. So you want to use that. It's running in your cell phone, most edge devices for ARM, NVIDIA if you want to do any gaming or graphics or even AI acceleration. And then of course, your MD say, but now, if you're in enterprise computing, you might run across our friend, what was known in the 60s, 70s, 80s, 90s as the IBM mainframe. It's been rebranded as Z17, as the System Z. We're up to the 17th version of the Z platform. And they're only released once every 2 or 3 years. So you can, that's already many years that it's been, that the Z has been available. They take the same hardware, rebrand it as Linux One, and then tune it for just running Linux virtual machines, either in LPARS or in ZVM or in KVM, depending on the client's requirements and preferences. So, and it's also the Linux One is a much lower price than the a fully blown mainframe, which is very interesting. And what you get is, low power. You get it's a RISC architecture, but it's also big endian, which is enjoyable in its own sweet way. There's you have all of these funky special attributes of the mainframe. You get hyper secure sockets, you get a lot of internal layered networking, network segmentation at the hardware level, which is pretty interesting. You get secure boot on all your VMs if you ask for it. You get in-memory data encryption, which is really nice if you're worried about rowhammer attacks. We share resources, except for the network and the hardware, between different essentially virtual machines. So if you install a Kubernetes cluster on LPAR, it's very much like a bare metal install. And then ZVM is the mother of all virtual machine hypervisors. In fact, VMware, the person that started VMware was an ex-IBMer that had helped develop ZVM. So that's interesting. KVM's a little bit more widespread use in the Linux world. And then, of course, you can run multiple operating systems in these virtual machines. ZOS, which is runs a lot of legacy software that you might have heard about in the federal government and other interesting places. And in Linux, we support RHEL, SLES, and Ubuntu and RH Core OS. Although you're not limited to those Linux versions. We have some clients that run their entire large operations on Debian, and we use Fedora for testing everything. So and the interesting thing about the Z17, if I can go in advertisement mode, it's just a little bit more, is that there's an AI acceleration component to the chip. There's an AI accelerator unit for every 8 CPUs on each of hundreds of cards in the mainframe. That's within that one cabinet there, and that's being used to accelerate things like fraud detection at the major credit card transaction companies. So you get these very, very high transaction rates, which the machine is famous for. And now you can do. When was the last time anyone has had a call like, "Oh, we think somebody's been using your credit card"? You ever get those calls? Um, you've been getting a lot fewer of them lately, and that's because they've automated a lot of those fraud detection processes. Okay, and I've put uh, the KubeVirt badge on this one because we have now ported and are testing and have released as a commercial product downstream KubeVirt. So that's great. The Power Platform is next on the list, and you get a lot of nice features with that. The IBM Spire Accelerator was announced a week and a half ago, and the general availability date on the Z17 platform is October 28th. We're going to be sending these PCI cards out to Z17 customers, and this is like a GPU, only it's, of course, better. Okay. Um, it's not that I have to say that. I actually believe that. So, in the Power Platform is the next thing on the list to work on, I think, in my opinion. So, we'll go on. So we've put together a multi-arch Kubernetes demo stack for KubeVirt in our IBM teamwork way. We've gotten help internally, and what we've done is installed Kubernetes control plane on 3 LPAR nodes, added, and this is the way you set up a multi-arch cluster in general, is that you set up a Kubernetes or OCP cluster on one architecture, and then you add worker nodes from the that you've pre-configured to the cluster. And then on the AMD worker node that we've added, we turned on nested virtualization because it was not a bare metal node as recommended, but rather we're in test mode here. Then you install KubeVirt 1.6 or later. There was a very key pull request that got merged this summer that has enabled this whole shoot and match. And then it's advised to install node feature discovery for S390X, and then label all your nodes with NFD so that Kubernetes and KubeVirt can know what the architecture is easily from a label rather than having to dig into it itself or have you manually label it. So that's sort of how the thing runs. Then I think, okay, then we set up, or David set up, and he's going to do the demo. So 2 virtual machines on 2 different architectures. So the procedure is to import a Fedora virtual machine for S390X, import a Fedora virtual machine for AMD 64, and to actually start running them in containers on the nodes that they that match their architectures. And it's there's a couple labeling procedures that are involved with that. Install an Nginx multi-arch container pod to house the sort of a landing page, add some interesting content to the 3 web servers, and then have the containerized landing page call each of the virtual machines web page from 2 different buttons. So this is
So shall
go
I
ahead.
just quickly share my screen and then?
Yes, and it's your turn. And here we go. Okay, sorry.
You have to. Okay. Perfect.
There we go.
Okay. So we have entire screen. So yeah, here's the setup, the 3-node with the additional compute node Cheryl talked about, and then I can show quickly the nodes here, and maybe also the virtual machines running there, and also there's this one pod here that's hosting like a landing page that we can quickly open up. And then just to showcase some use case here, for example, for S390X, there you have your corporate transaction and you need to run that. Then you can do that over here. This website is hosted on the LPAR, on LPO6 here. And if you need to do your, for example, CUDA workload where you have to do some inferencing and stuff, then you can do this from your classical AMD 64 node here. Yeah, that's actually, you already explained the whole setup here. That's a quick demo here. Back to you, Cheryl.
Okay.
Or in case we are done already, if you don't have anything else to say.
I have a summary.
Okay, perfect. Yeah.
Yeah. And there we go. So, yes, I took screenshots just to, in case, because that was a live demo, by the way. So, you don't necessarily want to leave yourself without a backup when you're doing live demos. So this is our summary. So we introduced the variety of different architectures to develop the multi-arch test suite. We described and ran a demo which runs a Kubernetes control plane on S390X, sets one node to worker/master, adds an AMD 64 worker node to the cluster, deploys an Nginx pod on the cluster, deploys a Fedora VM on the AMD node, deploys a Fedora VM on the S390X node, installs Nginx on each of the VMs, and then runs 3 web pages, a landing page that calls the other 2 from a button alternatively, an S390 workload, an AMD workload. They can be very different from each other, and that's good to do. I think that some more detailed documentation of both the setup and the runtime environment would be worthwhile, especially the networking, and to implement S390X VMs that exercise the special features of the mainframe to a greater extent, so that those can be tested in the KubeVirt environment. It would be nice to develop the multi-arch test suite, starting with this demo, and to make it part of the automated multi-arch testing in this CI/CD upstream and downstream, and to develop test rigs for key combinations. S390X and ARM would be the next one that we're interested in doing. AMD 64 control plane with S390X VM. It's the opposite of what we just did. And then AMD 64 control plane with ARM VM is something that you can try at home if you have like a Raspberry Pi or a cell phone and your x86 laptop. And we would like to also try some more interesting VMs and workloads. And then also the power port has been sort of started upstream. It's not an official project. I can't say really what's going on because we're not really allowed to talk about what we do internally until we make announcements officially. But I think this is like the next thing to do. And the nice thing that I would like to try is to repeat this whole multi-arch exercise with AIX, IBM I. That's the old I series, which used to be known as the AS400, which goes back decades, and but is still in active use and development. And to extend the VM boot to specialized hypervisors that are available on the zEmpower platforms. And these are our resources that are in our slide deck for people to access. And special thanks.
Just sorry, you're not actually sharing slides.
Oh, shoot. Oh, heck. Did I not hit the share?
I think one thing that's maybe very interesting here is the performance part, especially in the setup we've done here with bare metal cluster nodes, and then there's one KVM host or guest as a node. So yeah, that's also something some colleagues are looking at. I'm not sure if they're here.
Yes.
Back to you.
Okay. And then we have the written part of what I just talked about as well. Yeah, and performance with using different hypervisors, you can get a vastly different performance, different hypervisors and different control planes. So these are the resources that I was talking about, of course, the KubeVirt.io and all the rest of this is like sort of where these are the resources that we use to figure out how to do this demo. Let's put it that way. And then there's my famous KubeCon Cloud Native Lightning talk that I gave in Europe, and special extra thanks to a lot of people at Red Hat did so many things to help this sort of to help us contribute to this project. And at IBM Böblingen, this is basically the team that we've been working on the port to S390X. And Klaus has been helping us with setting up the cluster, the multi-arch cluster, and Holger Wolf is our fearless leader. And Anand Nakuti did the famous PR this summer that has made all this possible. So we're very grateful to everyone, and of course the whole KubeVirt development team. And I'm only a minute over. Okay, thanks. Bye-bye.
Yeah, maybe a quick note to I've seen in the Q&A from Lee linking an issue or an enhancement issue to KubeVirt. We're happy to take a look at that.
Okay.
And next, also excited to hear from you, Alexander.